Okay, so we're starting into inverse functions. We're going to learn about that right now. Your job pays you a base of $4 per week plus $15 an hour. The function for your weekly pay would be, we're going to do f of x is 15 times x. X is going to be our number of hours worked, plus 400. So we're going to calculate your weekly pay if you earn 23 hours. We put in 23 for x. We do f of 23 equals 15 times 23 plus 400. That's going to be $745. How many hours would you need to work to make $1,000? Well, we're going to set this equal to 1,000 and solve. I'm going to subtract 400 and then divide by 15. We find out that was 40 hours. So here I'm putting in my hours and I'm getting out the money I'm paid. Here I can put in the money I'm paid and get out the hours I'd need to work. So that's the inverse. If we did this function, that would be the inverse of this function. And that's the idea. It answers the question, what x do I need to input for a particular y output? All right. So inverse functions have lots of properties and stuff we're going to go over today. Tomorrow we'll do the algebra behind them and everything. The domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So you switch domains and ranges. The x's of the original become the y's of the inverse, and vice versa. So down here, you can see the original function of f started at 3, 0. Well, the inverse starts at 0, 3. Basically, it looks like here we're close to 4, 1. So we invert that and get 1, 4. And that's how you invert it. So like when you're doing the work, all you have to do is switch the x's and y's. The graph of the original is reflected over the line y equals x. That's this line here. The diagonal from bottom left to top right. Notation. Functions, we say f of x. This is the notation for an inverse. F inverse of x. That negative 1 is not the negative 1 power. It's just a symbol for an inverse function. Okay. Normally we do a vertical line test to see if something's a function, like this one. You run a vertical line. If it touches more than one part of the graph, it's not a function. For the inverse to be a function, it must pass the horizontal line test. You can see this starts to fail when it turns red there on a horizontal line test. In other words, no two inputs are mapped to the same output. Here, this would pass a horizontal line test, so it would be invertible. This one is not. Okay, state the domain and range of the function represented by the graph below. Determine if the function is invertible, then fill the sentence in the best possible justification. If the function is invertible, state the domain and range of its inverse. So the domain here is going to be all real numbers, left to right. The range, we go, somebody told me this, ceiling to roof. We start at 5 and go off to infinity. And we can include 5, so we need the square bracket to say we're including 5. We'll get to ones where they don't. Never use a square bracket with infinity. Infinity is not a number. It's a concept, so we're just going off to infinity. Invertible, no, it does not pass a horizontal line test. That means at least two inputs map to the same output. So right around 6 here goes to right around 8, and so does 0. So I have two x's that go to the same y. And it's going to ask you for an example, and you can put any number above 5. 6 would work, 7 would work, 8, any number even in between those. I put y equals 8, because if I go to y equals 8, it doesn't pass the horizontal line test. So over here, the domain starts at -5 and goes off to infinity. I'm sorry, -1 and goes off to infinity. Now this one, the range, we're starting down at -infinity and going to -5. So this is always left to right, smaller to larger numbers. Invertible, yes, it passes the horizontal line test. No two inputs map to the same output. So now we need the domain and range of the inverse. Well, you just flip-flop. The domain of the inverse is going to be negative infinity 5, and the range is going to be negative 1 infinity. Okay, your turn for these. Pause it here, work these out, and come back and check your answers. Okay, so this one's got a domain of all real numbers. The range is negative infinity to 0. It is not invertible, doesn't pass the horizontal line test. At least 2 inputs map to the same output. 0 goes to negative 1, and so does negative 4. I put example negative 1, has 2 different x's that go to negative 1. Anything below 0 would have worked as your example. Domain, this is an asymptote. It'll tell you this on Delta Math, that this is an asymptote, meaning it gets infinitely close to it but never touches it. So our domain is negative 3 to infinity, but we use a parentheses because we never actually get to negative 3. The range is going to be all real numbers. We're going nothing, no y we can't get. Invertible, yes, it passes the horizontal line test. No 2 inputs map to the same output. And then for our new domain and range, we just flip them. Domain is all real numbers. The range is negative and 3 infinity. And there you go. There's the beginning of inverses. Good luck.